I'm going to jump into SolidWorks here. I'm going to just go up here and just say File Open. SolidWorks gives us the capability of pretty much translating any type of component. So all I have to do is go down to my file types, and you can see that you can read in AutoCAD data, DXF included, and of course we have all types of 3D translators, Parasolid, iJust, Step, ACES, Native for Pro-E, Pro-E Assemblies, UG, Inventor, Solid Edge, CAD Key. So you have a toolkit right out of the box of QuickPress to pretty much, of SolidWorks to read pretty much anything. Let's read a neutral file format that's pretty common today called the Parasolid. The Parasolid, in this case, I'm just going to bring in a little electrical connector that's got some forming and some different types of features that we would see on a bigger part. But for the time's sake, we want to make sure we can at least accomplish this. Alright, to get started with, what we're going to do is we're going to go in here and change the display a little bit so you can see what we're dealing with. First of all, you'll notice on the left side of the screen, it's an imported model. There's no features, and that means that it's not native, and I do not have to recreate it. Be aware that many systems do need to recreate it to unfold parts. Now, let's go and jump right into QuickPress, and as you notice, QuickPress is embedded within the SolidWorks environment. You can utilize the pull downs, or you can do an unfold command just off the icons. I can give it a name, give it a project ID, and I might want to call it Feb 16, -1, and start my new project. Okay, so the first thing it does is we talk about unfolding. What we're going to do is tell which area is the die face. So we're going to unfold from there, and then allow it to automatically extract. Of course, all the bend compensation can be adjusted per feature. Let's find those features first, which is quite unique. So it does feature recognition. It gives me a bend report. It highlights the areas it can unfold. As you can see on the left, we now have an unfold manager. So instantly we get features that we can unfold. And yeah, there's a few that we can't unfold. I purposely do that to make sure that this is as realistic as possible, because I want to show you what we have to do if we can't unfold it. Let's start out by looking at what it automatically did. Notice that the right mouse button just allows me to unfold all, and we handle the material from a top and bottom, so material thickness variations don't bother us, and they bother all unfolders elsewise. Plus, we don't use a mid-plane approach. If you use a mid-plane approach and you thicken later, you can't handle metal deformation that is unique in a certain area, like a little chamfer. You can see here we have a chamfer on here, and we're going to help it out with that, but the majority of this stuff has all been unfolded, including the deformation like the round extrude. Now let's take this and go into user-assisted mode. User-assisted mode is our troubleshooting technique for parts that don't have absolute automation. And you can see here I can first of all tell the system what is the top and bottom material. I can also tell it exactly what these certain features should be. So I'm going to tell it this should be a form feature, and that's just one face. Okay, let's go to the next one, and I want to tell this one it's going to be a gusset feature, so I can help it out. Now we've got some nice little tools here, because you know gussets have lots of little faces, and this is a simple gusset, of course, but I'm going to surround the gusset, and then I'm going to have it auto retrieve the rest. So what we do is we just pick a couple of faces instead of 10, 20 little picks. You can see that we found that gusset quite quickly. Now we want to add another type of feature, and this is the most robust type feature for the most difficult multi-stage forming. We're going to do a two-stage forming in this case, but we don't know exactly where it's going to be formed. We're going to get started with adding a new feature called the user defined, and we're going to select these faces on this flange. Alright, so we have that. We may want to deselect a couple things and just say go. Now, what we've just done is we put that into a special state. And we have the final state of the user defined, and we have the blank state. Everything else can be automatically unfolded right now. As you see that very quickly I can get that information. Now on the left here you'll notice that step 0 has no geometry for the blank. Well, we have a couple choices. We can do our own rule of thumb and figure out what that complex forming should look like in the blank and draw it in. The other option is Quick Strip and QuickPress come with a freeform geometric unfolder to get you close. And then, of course, we do have another tool for more advanced forming called Quick Form. So let's show you a little bit about that. And we're going to do that by going back to this model, and I'll basically set up a press direction that's perpendicular to this little flange here. And the reason I want to do that is to make sure that when I do blank it, it's going to a proper plane. So we're going to put in that coordinate system, and it's pretty simple. I just pick this face. Alright, so now we know which way the press is going to be when we flange this down. So let's go to QuickForm in our tab here. On the right, we can create a new project. We can have as many projects as we want. We can also set up different press directions. We can tell it how we want to output the geometry. We can do it based upon a specific tolerance, and then pick OK. Now the next thing we need to do is we need to tell it what we're going to unfold, because we don't have to unfold everything, and that's kind of the whole point here, is we don't want to deform everything when we got 90% of it done already. I just want to do this outside flange here, and yes, you can offset it from midplane, that's okay too. And then the material thickness, material type, and of course any specific factors like lubricant. Pick OK, and now we can tell it to do its thing, which is, well, we need to hold it first, right? We need to make sure this thing is being held somewhere, so we're going to hold it along this edge and select this partial loop. So this way it constrains it so the red part flows, the yellow part stays still. Now let's go through there and automatically create the mesh and solve the problem. Let it take care of the math. So we run the project, and this is where it utilizes the ESI proven technology from Inverse. Comes back very quickly, gives us a blank just for that region. Let's hide a few things here so we don't have to look at those anymore. We also notice that we have the thinning plot. So I can hit show thinning and thickening, of course. Now let's take that and let's hide it, and let's use that geometry to do something. First of all, in this area right here, I may want to do a little bit of cleanup, so I can take this sketch and do anything I want with it. It's close, but I might want to tweak it. So what I'm going to do is take out a few pieces of information here and then just kind of clean it up, make it simpler is what I'm doing. I'm going to take that information, I'm going to take this entity, and I want to get this guy, just do a little bit of sketching in SolidWorks. So what we're going to do is take that and convert it into the current sketch. And then I want to make sure that I don't have any holes in there, so I can trim it up by going into Trim Entities, and then we'll corner these entities. So you can see that the 2D environment of SolidWorks is very easy to use, and of course you're working in a 3D environment on a 2D plane. So, alright, so we're going to take that and create our blank, and then teach QuickPress how that blank should play in the overall scheme of things. So we're going to take it and tell it which way the direction of the material is, and let's train QuickPress now. So we're going to take this, and we want to make sure that these connect. So we're going to fold this up, and then we're going to create a step 0 by telling it that's the top and that's the bottom. So this is a very good case where you can quickly do an accurate blank prediction but still maintain analytical information such as bends and localized and regional issues that you do not have to blank the whole part and then try to recreate it in the strip. Alright, so now we can see that we can take this and we can go through multiple stages. You notice that the form with the blank, and then we can fold that up and it's still formed, and of course we can keep on going through the different iterations.